Welcome back to All This Math. This is Professor Parker, and for this lesson, we're going to be talking about how to solve double absolute value equations. All right, double absolute value equations. Now, just like with most of mathematics, there's a few different ways to solve double absolute value equations, right? The way that I actually personally prefer to solve them is to basically treat them like two absolute value equations built into one, right? So, but I'm not going to do that method here. The method I'm going to employ here is where I set up a table with intervals, and then I basically create equations based on those intervals and then solve for x. And then I decide whether to accept or reject the solutions that I get based upon what my intervals are, right? So whether that solution falls within that interval or not is how I decide whether I'm going to accept or reject that solution, all right? So it's going to make more sense once I actually start working out the problem. Now, it's a step-by-step process, all right? So first thing we do, let's look at the problem. Let's look at the problem. Let's read what it is. It says the absolute value of 4x minus 7 minus the absolute value of 5x plus 2 is equal to 6. Now, let's make sure we understand what absolute value means as a concept. The absolute value is basically, if you think about a number line, how far away from zero is that number from zero on the number line? That's why absolute value will always end up being positive, because positive 5 is 5 units away from zero, so it has an absolute value of 5. Negative 5 also has an absolute value of 5 because it's also 5 units away from zero on the number line. So when you think of absolute value, try to visualize the number line and think of how far away that number or that expression is from zero on the number line. So first thing we're going to do is we're going to find what I like to call turning points. So what value of x in this absolute value is going to give you, is going to make this expression equal to 0. All right. We're going to do that for each of the absolute values. And that's important because 0 as a term, because when we find that number, that means, okay, at 0, you can either go positive or you can go negative. If you want to think again about the number line, if you're positive, you're going to the right. If you're negative, you're going to the left. So let's just do the algebra and just figure out what these turning points are, because that's going to be our first step. So in your notes, you might want to write that down, or I suggest you write that down. Step 1, find the turning points. Some people call them breaking points, but I call them turning points. So find the turning points. That's step 1. So that looks like this. So basically, you take each absolute value, the expression within the absolute value, and you're going to do 4x minus 7 equals 0. And you're going to do 5x plus 2 equals 0. And just simple algebra, you're going to solve for x. So we would add 7 on both sides, which gives us 4x equals 7. And then we divide by 4 on both sides, which gives us x equals 7/4. So that's one of our turning points. And then over here, 5x plus 2 equals 0. We're going to solve for x over there to find our other turning point. So we're going to subtract 2 on both sides. So we got 5x equals negative 2. Then we're going to divide by 5 on both sides. So we got x equals negative 2/5, right? So these are our two turning points. Now the next question is, well, what do I do with that? That's all fine and good. We figured out 7/4 and negative 2/5. What do I do with it? This is what you do with it. What you do with it is we're going to create a table. And this, like, some people might call this overall method that I'm using now is the table method, right? So we create a table. So this table, and the table is made up of intervals. So we got an interval that goes from negative infinity to our smallest value or smallest turning point, which is negative 2/5. Then we got another interval that goes from negative 2/5 to the bigger value or the next bigger value, which is 7/4. And then we got a third interval, which goes from our biggest value, 7/4, all the way to positive infinity. So that's how we got three intervals. So again, the intervals go from negative infinity to your smallest turning point. Then you got another interval that goes from your smallest turning point to your biggest turning point. Then you got another interval that goes from your biggest turning point all the way to positive infinity. So let me set up my table. I'll do my table right here. See, I got 1, 2, 3 columns. I got 3 columns because I got 3 intervals. 3 columns, 3 intervals. All right. So I'm going from, and I'm going to label it. So I go from negative infinity to negative 2/5. right? And I put parentheses around it because negative infinity is never included because infinity is not an actual number that you can touch. It's more of a concept. In the first interval, the negative 2/5 is not included, all right? What I do is, and some people do this differently, but I include the negative 2/5 in the next interval. So I'm gonna put a bracket next to negative 2/5 in the next interval. So that's gonna look like this. Negative 2/5 all the way to 7/4. That's my second interval. So my first interval goes from negative infinity to the smallest turning point, negative 2/5, all right? And then it goes from negative 2/5, which is included, to the bigger turning point, 7/4. All right, that's my middle interval. Then my next interval is also going to include the first value, which is 7/4. It's going to go from 7/4 all the way to positive infinity. All right, so these are my three intervals, right? And once I create my equations, then I'm going to solve the equations, and then whatever solutions I get, I'm going to test them to see if they're actually included within these intervals. And that's going to help me, that's going to tell me whether I should accept or reject those solutions. All right, now, we got our interval set up. The next step is we got to work with these absolute values because in our actual equation, we're going to drop the absolute value symbols. We're going to drop the absolute value symbols, just like you typically do if this was a single absolute value equation. You would drop the absolute value equation and then set up your two separate equations, right? That's what we typically do, right? Because this is a double absolute value equation, you know, and we're using the table method, it's a little more long and drawn out, the process that is. So what I want to do is I want to pick a value in this, and pay careful attention to this. You want to pick a value in this interval, plug it into this expression. And the question is, do you get a negative value or do you get 0 or positive? Negative or 0 or positive? If you get a negative value for that, right? If you get a negative value for that, that means that you're going to take the opposite of this expression, right? And that's going to be included in your equation. So it would be the negative of the quantity 4x minus 7. But if you take a value in this interval, plug it in for x, and then do the calculation, or evaluate it rather, and you get a 0 or a positive value, then you're going to keep it the same, all right? Because what we're doing is we're kind of mimicking the same process we do when we set up our two equations when we're solving a single absolute value equation, right? Remember, you have the one equation that's just the same, right? It's the same expression, except you just drop the absolute value. But then you got the other equation where you drop the absolute value and you take the opposite of whatever was on the right side of the equation, right? That's what we're doing here. So let's think of a value that's between negative infinity and negative 2/5. I'm gonna try to keep things simple. I'm gonna use -1 because -1 is less than negative 2/5. So it's in between negative infinity and negative 2/5. So I'm gonna use -1. So I take -1, right? And I plug it into this expression. I do 4 times -1, which is -4. The -4 minus 7 is -11. So that gave me a negative value. So because a value in this interval gave me a negative value for this expression, when I create my equation, I'm going to use the negative of 4x minus 7. That's very important to understand. That's very important to understand, right? I was studying videos on this method because, again, I'm not really a fan of this method, but it's a valid method. You know, it's cool, I guess. I was studying videos over and over again, and that was the part that I kept getting caught up on, right? But then it started to make sense. Once I kept studying and kept practicing the problems and doing the problems on my own, then it kind of started to make sense. And I started to understand why that step is necessary. So I got a negative value for 4x minus 7. So that means that in my equation that I create next, in my next step, I'm going to use the negative quantity of 4x minus 7. If I had got 0 for this, or a positive, or just a non-negative, we can use the term non-negative, which represents 0 or a positive, then I would just use plain 4x minus 7. Just plain old 4x minus 7, right? So you got it, and we're going to do this. We're going to do this 6 times. We just did it once. We're going to do it 6 times. Why 6 times? Because we got 2 absolute values, and we got 3 intervals. 2 absolute values, and we got 3 intervals. So we got to do the test 6 times in total. We already did it once. We did it with 4x minus 7 in the first interval. Now we're going to do it with 5x plus 2 in the first interval. Now, I'm gonna use the same number because I still need a number in this interval. So I'm going to use -1. So I do 5 times -1, which is -5. What's -5 plus 2? -5 plus 2 is -3. So I get a negative again. Now, because I get a negative, that means I'm taking the negative of this expression. So it's going to look like this: -5x plus 2. And we got to do that for this interval and this interval also. So now I go to this interval, right? -2/5 to 7/4. I know a number that's real easy to use that's in that interval. 0. 0 is in between -2/5 and 7/4. So let's just use 0. Plug 0 in, or evaluate 4x minus 7 as 0. That's going to be 4 times 0, which is 0, and 0 minus 7 is -7. So we end up with a negative. So remember, what do you do when you end up with a negative? You take the negative of this expression. So that's going to be just like this one over here. Negative quantity 4x minus 7. All right, because we ended up with a negative. Now, I know you might be thinking, well, we keep getting negatives. Are they always all going to be negatives? No, it's a coincidence. Sometimes you'll get negatives and you're going to get negatives and positives. All right, it just depends on what the numbers are and basically how things work out. Now we got to do 5x plus 2 in this interval. So I'm going to use 0 again because 0 is in this interval. So I do 5 times 0, which is 0, and 0 plus 2, which is 2, a positive, a positive. So we didn't get a negative. So because we got a positive, we keep the expression 5x plus 2 the way it is. So we got 5x plus 2. All right? So notice for these first two, we take the negatives of the expression. For this one, we take the negative of this expression. For this one, we take the positive of this expression, or the regular expression, 5x plus 2. All right? So now we're going to do the test in the last interval 2 more times, just 2 more times. We did it 4 times already. Now we're going to do it 2 more times. We need a value that's between 7/4 and infinity. So 7/4 I know as a mixed number is 1 3/4. 1 3/4 is a little less than 2. So I know 2 is in this interval. So I'm going to use 2. And you can use any number you want as long as it's within the interval. So I plug in 2 for 4x minus 7. 4 times 2 is 8. 8 minus 7 is positive 1. So I got a positive. So when you get a positive, you use that expression. You just keep that same expression. You don't make it negative. All right? So I'm going to just have 4x minus 7. Then I go to 5x plus 2. And I do 2 times 5, which is 10. And 10 plus 2 is 12. Another positive. So another positive. So I'm just rocking with 5x plus 2. All right. Now, what's going to happen next is I'm going to take these expressions and I'm going to create my equations, right? I'm going to have 3 separate equations, and then I'm going to solve those equations for x. And then depending on what values I get, what solutions I get, then I go back and I say, okay, is the solution I just got, is it in this interval? So when I create the equation using these 2 expressions, negative quantity 4x minus 7 minus negative quantity 5x plus 2. Be careful with all those negative signs. Be very careful with all those negative signs. Is equal to 6. I do all the math correctly and I solve for x. Then whatever solution I get, if that solution, I got to test it to see whether I want to accept it or reject it. Am I going to accept the solution or reject the solution? Now, if that solution is in this interval, then I accept it. If it's not within this interval, then I reject it. And that's not a solution. I do the same thing for the equation that comes out of this interval. Then I test it. I solve for x. I set up the equation. I solve for x. And then once I get the x value, then I either accept it or reject it based on whether that solution is in this interval. Then I do the same thing for this interval. All right? I'm going to do the same thing. Okay? So let's get to that. That's going to be our next step. All right? Next step, we're going to set up our equations, solve our equations, and then accept or reject the equations. All right? So we gotta write these equations out, and it's gonna be 3 equations, like I said, and then we're gonna find the solutions to these equations, and then once we find the solutions, we're gonna test them to see whether we should accept them or reject them. Right? We're gonna keep them and say, okay, this is part of the solution set, or we're gonna reject them. So get out of here. We don't want those solutions, right? But before I do that, something I neglected to do at the beginning of the video was talk about why I got this hoodie on, right? This is my Central High School hoodie. Central High School located in Philadelphia, near Broad and Olney, as we call it, B&O, right? I taught at Central for a year. I taught math at Central High School back in 2015. I taught like 3 sections of geometry, like 2 sections of algebra 1. That was a good experience for me. It was very fruitful. Also, my motivation for creating this video is for a young brother named Akinsheye, who actually attends Central right now. So that's another reason I wanted to throw this hoodie on, right? But Central is important to me, but for a reason that might not be, it might be for a very unique reason. The reason that Central is important to me is because there was a brother named Alain Locke who attended Central, who was from Philadelphia. He attended Central. Alain Locke graduated from Central and then would go on to get further education and then ended up earning a PhD. And after that, he then went to DC, Washington, DC, and actually taught at Howard University. And then after teaching at Howard University, or either maybe while he was still teaching at Howard University, he compiled an anthology of writing entitled The New Negro. This is like early 20th century type time, right? So it's entitled The New Negro. Now within The New Negro, right, this is where it really gets special, right? Because we're talking about genealogy here, right? So within The New Negro, there was an essay entitled The Negro Digs Up His Past. The Negro Digs Up His Past was authored by a brother named Arturo Schomburg. Arturo Schomburg is a brother who was a bibliophile, a scholar, historian, lived in New York City, and was just very influential to the African-centered studies movement early in the 20th century, right? Dr. John Henrik Clarke, when he was a youngin', found this book and found the essay within the book and read it. And when he was young and living in Alabama, before he migrated north to New York City, or Harlem more specifically, he wanted to meet Arturo Schomburg in order to converse with him about what he wrote in this essay, right? So, and this essay was very influential, and Dr. Clarke spoke about this, in interviews and whatnot. He talked about how this essay, The Negro Digs Up His Past, which was about African history, it was about Black history, about African American history, or whatever you want to term it, how influential it was to him in putting Dr. Clarke onto his trajectory to become the African-centered scholar and teacher and lecturer and historian that he would ultimately become, right? So that's the connection, right? So Dr. Clarke reads the essay, The Negro Digs Up His Past. The Negro Digs Up His Past was published in a book called The New Negro. The New Negro was edited and compiled by Alain Locke, and Alain Locke was a brother from Philly who graduated from Central High School. So, and all that stuff is very interesting to me, and that's kind of how I remember history and how I learn history. I always look for connections. Like who knew who, who was with who and whatnot, and who was hanging out with this person, and was this person hanging out with that person, and who studied with who and all that. And that's just how I learn things anyway. So this is why, Central High School is significant. And that's kind of a unique reason for it to be significant, but that's what works for me. I'm all about, how is this place related to something that's African-centered, right? And that's a way that it's related to something that's very African-centered, because Arturo Schomburg and Dr. Clarke were very much African-centered, all right? And they've influenced me greatly as well. So moving right along, as I said, we got to create our 3 equations, and I hope I'm gonna have enough space on this board. What I might have to do is do one of the equations and then erase it. Actually not, because I want to leave it up here. But we got to do 3 equations, and then we're going to accept or reject the solutions, okay? So our first equation is going to look like this. It's going to be based on this original equation, but except we're going to use the negative quantity of 4x minus 7 and the negative quantity of 5x plus 2. But we got to be careful because there's already a minus sign there. So it's going to be a bunch of negative signs. So you got to be careful when it's a whole bunch of minus signs, because you got to stay real organized. All right, so watch this. We're going to have negative quantity 4x minus 7 minus, now watch what I do. I'm going to do the bracket to keep everything kind of neat, right? And then I'm going to have negative quantity 5x plus 2 is equal to 6. All right, and peep why I use the bracket, because again, it's minus this expression. So I don't want the minus signs just next to each other like that. So I put the brackets to kind of separate the minus signs, or separate the minus sign from the negative sign. All right. So then I'm going to just distribute these negatives. So this is going to become negative 4x plus 7. And this is going to become minus, let's see, negative 5x minus 2 is equal to 6. So look what I did. This became, look at the progression from here to here. This became negative 4x. This became positive 7, because negative 4x double negative 7 is plus 7. Then I still got the minus sign and the bracket, and here we got negative 5x, and here we got minus 2 equals 6. So now I'm going to distribute this negative to both of these terms. Both of these terms. I'm going to distribute this negative. It's really a negative 1 that's being multiplied, right? So we got negative 4x plus 7 plus 5x plus 2 is equal to 6. All right, so look, plus 5x plus 2. Plus 5x and plus 2, double negative again. Then we combine like terms. What's negative 4x plus 5x? That's just x. And what's 7 plus 2? That's 9. Equals 6. Subtract 9 on both sides. Minus 9, x equals negative 3. All right, now, that's our solution to this equation. Now our job is to go into the interval and say, is this within the interval? And yes, negative 3 is within the interval. It is between negative infinity and negative 2/5. It is. So therefore, we accept this. We're going to accept it. Cool. This we accept. All right, we're not going to reject it. We're going to accept it. So this is one of the solutions. All right. This is one of the solutions. X equals negative 3. And also, we can just take this and just plug it in right here and see what happens. What's 4 times negative 3? Negative 12. What's negative 12 minus 7? Negative 19. What's the absolute value of negative 19? It's 19. All right, and then we got 5 times negative 3, which is negative 15. What's negative 15 plus 2? Negative 13. Negative 15 plus 2 is negative 13. What's the absolute value of negative 13? Positive 13. So we got 19 minus 13. Does that equal 6? Yes, it does. So that's proof that this is a solution. That's proof this is a solution. All right, we did that equation. All right, so we got that one out the way. Now we got 2 more equations to do using these 2 expressions. So now I'm going to do negative quantity 4x minus 7 minus the quantity 5x plus 2 is equal to 6. That's my second equation. All right, my second equation. All right, I distribute the negative sign. That's going to be negative 4x plus 7. Distribute the negative sign. That's going to be minus 5x minus 2 is equal to 6. Combine the x terms. I got negative 9x. The 7 minus 2 is 5 is equal to 6. I got negative 9x is going to be equal to 1. Where'd the 1 come from? Subtract 5, subtract 5, subtract 5, subtract 5. Now, this is going to become x equals negative 1/9. How? Because I divide by 9, 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 right? Keep the balance, right? In equations, when we solve equations, we keep balance. Just like Mayat, ancient Kemet. We divide by negative 9 on the left, we divide by negative 9 on the right. Now, I got to go into the interval and see if this is a valid answer. Is this number in this interval? Is negative 1/9 in between negative 2/5 and 7/4? And yes, it is. It is. So that means we're going to accept this. We're going to accept this. So this, we accepted negative 3, and we accept negative 1/9. All right. Now, last equation, based on these two expressions. So we're going to have, let's see, 4x minus 7 minus 5x plus 2 equals 6. We're going to solve that. So we got 4x minus 7 minus 5x minus 2 is equal to 6, right? Combine the x's. 4x minus 5x is negative x. Combine the negative 7 and the negative 2. That's minus 9. That equals 6. Add 9 on both sides. We got negative x equals 15. And I want to get x by itself, not negative x. A lot of people make this mistake. They get to negative x and they think they're done. You're not done when you get to negative x. You're done when you get x by itself. So we're going to divide by negative 1 and divide by negative 1. So x equals negative 15. X equals negative 15. Now the question is negative 15 in this interval? It's definitely not in this interval because this interval is all positive from 7/4 to infinity, or 1 3/4 or 1.75 all the way to infinity. This is negative. So we're going to reject this. Reject him. Get him out of here. Reject x equals negative 15. Get him out of here. That's no good. So our solutions are negative 3 and negative 1/9. And that is how you solve a double absolute value equation using the table method. All right. First thing, you find your turning points. You look at your absolute values, you pull those expressions out of there, right? And you find out what value is going to give you 0. Those are what we call our turning points. We use the turning points to create our intervals, our intervals. So we go from negative infinity to the smallest turning point. Then we go from that turning point to the next turning point. And then we go from the next turning point to infinity if we only got 2 turning points. If we had 3, and if we had 3 absolute values, then we would have an extra column, right? Then within here, we want to know, are our expressions going to be regular or are they going to be the opposite? Meaning, are they going to be negative? Are they going to be regular or negative? The way you figure that out is, and this is very important, you pick a number from in the interval. You pick a number from in the interval and plug it in to the expression that was inside the absolute value. If you get a positive or a 0, that means you keep it regular. You keep that expression the same. But if you get a negative value, that means you're going to write it as a negative. So the negative quantity of whatever the expression was. All right. Then you create your equation, and each interval gets a different equation. Each interval has its own equation. This was the equation for the first interval. This was the equation for the second interval. This was the equation for the third interval. Then when you get to your solution, right, you take your solution and you basically test it inside the interval to see if you want to accept it or reject it. Notice, because we got negative 3. That was in the interval, so we accept it. We accept it. Then we got negative 1/9 for this equation. That was in the interval, so we accept it. Cool. Then we got negative 15. But that's not in this interval. And since that's not in this interval, we reject it. Get it out of here. We don't want it. All right? So, I know this problem took a long time. It's a lot. It takes a lot to explain it. But you got to practice these. Like I spent a lot of time the other day really practicing these and going over these. And I hope it makes sense. Now, this is not the only way to solve double absolute value equations, but this is one of the ways. And it seems to be kind of efficient. So it's good to know how to do it this way. All right. So I showed you how to do it. Use this video as a guide and go get some practice. Go get some practice and do a bunch of these on your own. All right. I'm also going to have a video on solving double absolute value inequalities pretty soon. So be on the lookout for that. All right. Peace. Go get some practice.